Hi everyone, today's topic is the volume of cones and spheres. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But don't fast forward so much that you miss out on something important. So last time we talked about cylinders, and today we're talking about cones and spheres. Those three actually all belong to what I call the curvilinear family. They're all three-dimensional shapes. They all have curved faces. They may or may not have, vertex or vertices or edges like other normal, typical 3D shapes. But for all of them, if you were to cut into the shape, if you make a cross section, you'll find a circular cross section. So they all are related to the circle in some way, shape, or form. So with that being said, those three are actually related to each other when we look at their volumes. Remember, the volume of a cylinder is pi times r times h, or the radius and the height. So I want you to make a prediction before I show you a video of how they're related. In your prediction, I want you to think about the volume of a cone and how it would relate to the cylinder's volume. And for the volume of a sphere, how would it relate back to a cylinder's volume as well? So I'm giving you a major hint that they're all kind of date back to the cylinder. They're all related to the cylinder, the sphere and the cone. And when I want you to make that prediction, I want you to imagine that we're looking at three different shapes with the same height. In this picture, they don't really have the same height, but they would have the same height and the same width. So just as tall and just as wide for all three. How do you think that those three shapes' volumes would be related to each other? Okay, once you're done making your prediction, we're gonna watch a video where we will see those three shapes with the same height. So if you notice, they have the same height. And if we were to take a ruler, they have the same width as well. Okay. Some of you might predict they have the same exact volume. Others would predict they have a fraction of another one's volume. So we'll see what the answer is. And of course, this relates back to the volume formula. So it's going to help us remember the formula. Same height. So we're going to compare the cylinder and the cone first. Same height and same width. Remember, volume is the amount of space inside. So that's why we're using water. So we're going to fill it up until the cylinder is all the way full. So you should have figured out by now that if three of those cones' volumes fill up one cylinder's volume, then one cone's volume would be 1/3 of a cylinder's volume. So that's how those two are related to each other. If a cylinder's volume is pi times radius times radius times height, then a cone's volume would be just 1/3 of that. It's the same formula, pi times radius times height, but 1/3 of it. So you can write it as 1/3 that volume, or you can take that formula and divide it by 3, or you can write it all on the top and then divide by 3. Those are just 3 different ways to write it, because a regular cone contains 1/3 the amount of a regular cylinder. Write that down in your notebook before you forget it. And you might want to draw a picture as well from the video that 3 of those fill up one 3 of those cones fill up one cylinder, or just show that it fills up 1/3 one time. And then once you're done with that, we will continue with the video so that we can look at how the sphere is related. And you might want to change your prediction for the sphere's relationship before we start. Okay, so it looks like the sphere is 2/3, because it went up 2 of those notches, and those are dividing the cylinder into thirds. So the volume of a sphere is 2/3 the volume of a cylinder. A regular sphere contains 2/3 the amount of a regular cylinder. You could write it as 2/3 multiply by the formula of a cylinder's volume, or do the cylinder's volume, multiply by 2, and then divide by 3 in your calculator, or you can put the 2 on the top with the numerators and 3 on the bottom as the denominators. Those are just 3 different ways to write that. So the sphere takes up 2/3. If I were you, I'd also draw that in your notebook so that you have a visual way of remembering that as well. So that would be an easy way for you to remember the formula. Okay, and then we're going to finish up this video because it looks like he kept the volume of a sphere in there, and now he's going to dump the volume of a cone in there. So if you wanted to add something else as well, it looks like the volume of one sphere and one cone fits into the volume of one cylinder. So they all go back to the cylinder. All right, let's do some practice problems. So the volume of a cone, that's what they want you to figure out here. Go ahead and pause the video, see if you can remember the volume formula after watching that video, and try it on your own first. All right, so the cone, volume of a cone, that one was 1/3 the volume of a cylinder. So we're going to take, and they said we can either use pi or 3.14. I'm going to use pi because it's one less thing I have to multiply. Multiply by the radius. The radius is from the center to the edge, so that's 5. 5 units times another 5 units because it's radius squared. And then multiply by the height. The height of this cone is 3 units. It's 1/3, so I'm going to take that and divide by 3 units. Oh no, not 3 units, but just by 3. 1/3. If I were to solve this math problem, without a calculator, I could do that because I have a multiply by 3 and I have a divide by 3. So that's going to make my calculations easy. I'm just left with 5 times 5 on the top. That's 25 and a pi. And I have units times units times units. So that's units cubed. Only the 3's canceled out. The units is still there. So you still have that third unit. So this answer should be 25 times pi units cubed. If you use 3.14 as your pi, you would have gotten whatever the answer is for 25 times 3.14. So you could have also gotten 78.5. Okay, so that's the volume of cones. If we were to solve the volume of spheres, we would just use the spheres volume formula. Pause the video and try this on your own first. Okay, so the volume of a sphere, if we remember from the video, it's 2/3 the volume of a cylinder. So 2/3 times pi r squared h. I'm going to keep pi as itself. That 3 is on the bottom. The radius is 9, so 9 units times 9 units again. The long numerator. And then here's where people usually get tricked for the sphere. There's no height, right? They didn't give us a height. So we have to figure out on our own what is the length from the top to the bottom. The only information we've given is the radius. From the center to the edge is 9. So think to yourself that this sphere is the same on all edges, right? So we can assume that from this center to this edge is also 9. And if everything is symmetrical, which it should be for a sphere, then it should also be 9 from the center to the top edge. So altogether, the height should be 9 plus 9, which is 18 units. So the height is hidden there with the radius. So the height is basically the diameter. And diameter just means it's the length from one edge to the other going through the center. So it's double the radius. So all this information is given to you with just the radius. The radius is basically half of that height, half of that diameter. And so all you have to do is multiply the radius by 2 to get that height. So we end up with this math problem, and I love canceling things out if I can. The 9 and the 3 can become a 3 and a 1, because 3 times 3 gets you to 9. So you're basically canceling out. You're taking out the factor of 3. 9 is basically 3 times 3, and 3 is basically 1 times 3. So you're taking out both of their 3's. And then you're going to multiply. If you don't like reducing that, then just multiply it all the way through and then divide by 3. But if you are reducing, then in your calculator, you're just doing 2 times 3, because that's what's left over, times 9 times 18. And then you don't need to divide by the 3 on the bottom, because you already reduced it to a 1. Again, if you don't like reducing it, you'll just do 2 times 9 times 9 times 18 and then divide that by 3. And you'll also get 972 pi units. If you want to put the value of pi in, you'll just do 972 times 3.14 to get the answer. Oh, and that is cubed for the units, not just units. Okay, let's do one more for the spheres because the height can be a little confusing. Oh, yes, let's definitely do this one. So go ahead and pause the video, try this one on your own first. All right, so volume of a sphere is 2/3 the volume of a cylinder. So we're going to use pi by itself. I'll show you later on how we can do the 22/7 for pi. So let me keep 3 on the bottom as the denominator. Rewrite this. So you're basically dividing by 3 at the very end. My radius is 1/2. And then my height is going to be from here to here, this entire thing. We know half of that is 1/2, so we're going to need another half of that. So 1/2 plus another 1/2 is going to be 1. Okay? If I have half of something plus another half of something, those two halves just make up a complete unit. So those two radiuses, radii, together will make the height. So it's just 1 unit, units, whatever. All right, so you could put this into your calculator now. A lot of people like to change fractions into decimals and then put it into their calculator. So in your calculator, you're just typing in 2 times 0.5 times 0.5. You don't really have to multiply by that 1. And then you're going to divide that by 3. The other way you can do it is just to do your math with fractions, okay? So 2/1 times 1/2 times 1/2, okay? That's the top part. All right, so then I'm just going to multiply across 2/4. That's the numerator. I haven't divided by 3 yet. So that's the numerator. I'm going to take that numerator and I'm going to reduce it to 1/2 because I can do that. That's the top half. Dividing is the same as flipping it and multiplying. So instead of dividing by 3, I'm going to multiply by 1/3. So that's some fraction work for you. Okay? So instead of dividing by 3, I'm going to multiply by its reciprocal, 1/3. So the answer is 1/6. 1/6, oh, forgot about the pi, units cubed. That's one way you can do that. They said the other way is that you can use 22/7 for pi. So all that means is instead of 3.14, you can put in multiply by 22.7. And then you'll get 22/42, and then you still got to reduce it. So that's the bad thing about having fractions is you got to work with fractions. And some of us don't like to work with fractions. 22 divided by 2 is 11. 42 divided by 2 is 21. So you get 11/21 units cubed. Okay? So they're saying instead of using pi as 3.14, you can use 22/7. If you were to use 22/7, 22 divided by 7 is pi. That's just another approximation of pi. See how it gets you kind of 3.14? So you can either use 3.14 or if you're dealing with fractions, people like to use 22/7 because that's the fraction that gets us closest to pi. And that's just dividing 22 by 7. So again, the other tricky part here is instead of the top answer, after we did all that fraction work, instead of dividing that by 3, it's basically the same as multiplying by its reciprocal. So that's the key there with fractions. Okay? Make sure you take notes on this problem in case you get another fraction problem. So we just did the top math and then divided by the bottom's reciprocal. Multiplied by the bottom's reciprocal. Multiplied by 1/3. All right, let me know if you have questions as you work on these problems, and I'll see you in class.